Hello, please have a good day. My name is Saul Montoya. I'm from Hatari Labs. This time we are going to do a tutorial on hydrological modeling at Basin scale with HEC HMS. Okay, so you will receive these files that are mostly the data that, no, sorry, no, these files, you will receive, not these files, sorry, you will receive another files. You will receive the files that you need to do this exercise. Okay, and these files are, let me show you. Um, yeah, the files that you will receive are those. This is a Excel file and a TIFF and a map. Okay, so in order to do this tutorial, you will need to have HEC HMS installed. So what we will need is to deploy our HEC HMS. Okay, this is HEC HMS. Okay, we open it. Okay. This we are going to define a new project. So we create a new project that we'll call Tifton sample. And where we are going to locate it is we are going to do here a folder on our documents. I strongly suggest that you do the tutorials on your document, on your My Documents folder, because it's since you are learning and going with and trying to make your models, to your first models, it is available that everybody has the same root. As you see here, I don't use any, and for any folder that I have, I don't use spaces, and I don't use, for example, tilde, because and I don't use very long uh, routes or folder names, because those are as well a reason why some programs do not run. So please put it here on your document and create a TIFF samples. This is the folder that you will use. Select. Yep. And then here in TIFF sample, you will have this this project, and we will use the US customary because this exercise is on the imperial unit system. Create. Okay. Great. What else? We are going to component, and then we are going to create a Basin model manager. And here we say Basin, and the Basin will be Tifton, new, and this will be Tifton. Create. Cool. What else? Then we have our Basin, and this is the canvas of our Basin, but it's mostly empty. Okay, so then we create a new model. So we go to then we have created a new Basin model, and then we import the background maps. View background maps, and on the background maps we are going to add a background map, and this will be on documents. On Tifton, that is the data that we will give you. You don't have a srich files where you have a HEC HMS map file, and here is tifton.map. Okay, cool. Here we have the tifton.map. Okay. Then what else we are going to do? then we are going, this is the only the background map, but we have to insert our elements, and we're going to have only two elements. That is a sub-basin that will be located here. Sub-basin, this is will be called 4006 create, plus a junction that will be located here. This is sub-basin, this is reach, this is reservoir, this is junction, this is diversion, source, and sink. So this junction will be located here and will be station 1. Station 1. Station 1. Okay, create. Cool. Then what else we do? We are going to apply the hydrological methods to our basins. So here on this one, we are going to define downstream of this basin will be station 1. So here in downstream, I just put station 1. Okay, and when I select any other element, it appears the connection here to here. Okay, cool. The area will be of 19.27 square miles, and the methods here will be simple canopy. The surface method will be simple surface. Yeah. Loss method, soil moisture accounting, that is one of the most complex methods in HEC HMS. Clark unit hydrograph, and linear, here this one be linear reservoir. Okay, so just to here on the basin that is called 74006, we're going to insert the area of the basin and the hydrological methods: simple canopy, surface, soil moisture accounting, Clark, unigram, and linear reservoir. If you see, there is for every method, like it has appeared, like let's say a new tab here. So okay, we have to define the methods for every tab. So for canopy will be 80, maximum storage 0.2. Okay. For surface will be 80. This will be 0. For loss, it will be 80, 0, 2, 2.2, 0, 9, 9.5. And those are values that come from, actually this is a example from the HEC HMS documentation. Yeah, but I mean, the question of this is, where do I get those values? Those values actually come from the calibration, because actually you don't know. This is a conceptualization of how your groundwater flow system happen on the basin. Some of these parameters can be related to physical tests, but most of them will be just a sort of feeling of what could be that parameter. And this feeling that what could be this parameter has to fit the observed heads that the observed values that you get from at the station. Okay, so 80, 0, 2, 2, 0, 9, 8.5, 002, 10, 002, 100, 24, 0, 500. Great, a lot of numbers if you see. Then we go to transform, where we put the concentration time, that is 20 hours, and the storage coefficient, that is 24, 24, and time area default. Cool. And then on Baseflow, we put this 0, 40, 1, 20, 240. Cool, great. What else do we use? Nothing else. Then we go to station. On a station, we don't do nothing because there is no parameter here. And then we go to precipitate, to here, to components time series data manager, and here I put a precipitation gauge that will be called gauge 38. Okay, on gauge 38 will be nothing else. We close here and then we go to gauge 38, and here is time manual enter incrementing and 15 minutes. Okay, okay, cool. Then we expand this, and then here the time frame that we are going to use is I am my operating system is in Spanish. That's why it appears here N, but is similar to January. So you will find this on the local format of your computer. Okay. So please keep in mind that this will be different for you. Okay. 1, 2, 23. Okay, cool. And then here I go to table, and on the data that you will receive, there is a Excel file. The data for this is gauge 38, and I just can. It's a lot. I think I can get. To select the whole here, Control C. You put Control C or copy, and then you put Control V on paste, and then you see the graph. Do you see this graph? Yes. So this will be the precipitation. Sorry. These are cumulative inches. Okay. 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 So these are, based on here. Yeah, these are cumulative inches. Yes. Okay. So here you have cumulative inches, manual entry every 15 minutes. And then when you put cumulative inches, here it appears this one is the first one, and then you have this. Okay, cool. So the precipitation is, sorry, let me check. Ah, okay. Okay, I will paste again. Once again. And I go here and then I put it here. And I go to graph. And yes, if you see this will change your values. Yep. So, okay, like I can delete, yep, and then I paste it, and this change my values because actually what you have inserted here are the cumulatives. Yep, but this is going to separate it in the precipitation of the day. Okay, cool, cool. Yep, yep, yep. Okay, ready, ready, ready. So cumulative inches, 15 minutes. Yeah, it changes from 0 to 23, and it changes what you have inserted because actually it gives you this one give you the precipitation in the day, while you at the beginning have inserted the cumulative inches, and this is the graph. Okay, great. And then what else? Ah, okay. Till this moment, components. Yeah, I'm going to save my project. Okay, and then here I'm going to do a backup of the project. Give an example. Okay. Ah, okay. I cannot do. I have to do a copy. Okay. Okay. Cancel that. Okay. I have to do a cap here. So I just save. I just close my HEC HMS. I close this as well. I save my, and then I do a backup of my Dixon example. You will receive as well this backup, and then I open again HEC HMS. This is a very nice example in order for you to learn how to close and open a project. So we go to Tifton example, and then Tifton example, and then here is the Tifton example HMS. So I select, and here I have my Tifton, my Basin is the same, and here on the precipitation gauge, I have my cumulative inches, and here I have the graph that I have shown. Okay, cool. Then we're going to insert a discharge gauge. So here we go to the meteorology, no, to the time series data manager. I go to the discharge gauge. I set that new. I put gauge 1. I create it, close this. Time series data, discharge gauge 1. And from here, I'm going to insert that I will insert the values of cubic feet per second of the every 15 minutes. Okay, cool. And then here I'm going to insert from the 1st of January of 97 to the 30 of June of the 97 at 23 And my data is, let me check my data, which is the, on the gauge, I have data every 15 minutes. Wow, I have a lot of data. So just to recapitulate, okay. Sorry, what happened here? It got stuck. Wow. Okay, cool. I don't know. So, okay, so it's every 15 minutes, cubic feet per second, and it goes from here to here. Okay, this will be different for you. And on the table, here, I am here. I just press Shift, and then I go to the beginning. This is here. And then I just paste this, paste. Takes some time. If it is working, no, it's not working. So okay, here I have to put Control C, Control V for paste, and then I have the graph, and this is the graph of flows. This is the flow graph. Yep. Okay, and then we are going to save it again, and then we are going to make a meteorological model manager. Meteorological model manager, new, that will be Met1. Okay, on Met1, on meteorologic model, here we have Met1, and on Met1 we are going to, the precipitation will be specified yetogram, the evapotranspiration will be monthly average, yeah, and the unit system will be metric, yeah, no, US customary, okay, cool. So then on basins, we say Tifton includes subbasins, yes, yeah, otherwise we cannot put it, yeah. In options, oops, sorry, meteorological options, total override, yes. Replace missing, no. Okay. Then we go to specify yetograph, and here we put that this will be the precipitation for the basin will be the gauge 38. Okay, nothing else. And for the basin, the monthly average will be these values here that you find here on the, it will be these values that will put Control C, here I put Control V. Okay. I suggest is that you, if you have lost, you repeat this video because it will be easier. My steps can be much faster, much faster. Okay, so I go on components, I put control specification components, I make new, I put control 1, or like I say, like it says January 1 to June 30 of create. I have created a control specification function that actually put or set up which is your, this one actually set up which is your the time that you will make your simulation. Okay, and from here we are going to say that this from the first, yep. You can do this, you can just copy this, and then you just paste it here. The time is 0100 because it's actually the same. 30 of June. Okay, and this is every 1 hour because we don't want to simulate our model every 15 minutes because it will be so time consuming and as well computer consuming step. So we did it just every 1 hour. We can say that's every 1 day. Okay, we save our project again. And what else? We go to compute, create compute, simulation run. We have a run one. Next, we will do it with Tifton. We do a meteorological model, and on this period, and then we run. We have created a simulation run. Okay. Then, if you go here to compute, you have already your first run. So if you do right click, you say to compute, and here I say, here it comes with a problem. I say, for you it can be other problem. I say, Yetogram on gauge 21 for it contain missing or negative precipitation values. So I go back. This can be different for your because maybe you haven't done this. So I go to precipitation gauge, and here it says I have 362 values where I don't have nothing. But I have it for January only. Cool. So here you have it from the 1st of January every 15 minutes to the 30th of June. And here you have the 1st of January to the 30th of January. Ah, okay, cool. This is of June. Okay. So this, yeah, it's right. Okay, it's creating the empty spaces. That's why my computer is kind of locked now. And I have to select all of these here, all of this. I made a mistake, sorry. Okay. On the table here, yeah, it's true. So I just put here, put the graph here. Okay, cool. That's it, because I only had January because my fault. I have only said that my values were only for the 1st of January. I save it. Yep. I save it and then I run my model. I go to compute and then I go to run and then I say compute. Okay, and they say, okay, you have finished your result. And then we can go to results and then you can see on the run global summary. You have here the drainage area, the peak discharge, and the volume. And here you have the graph where you see the runoff, the base flow, the precipitation, and the loss. This is the outflow. This is the potential evapotranspiration, canopy, cumulative precipitation, saturation, and this, since you are using the SMA, these are the whole values. And on the station 1, you have the graph. These are the element. This is the simulation. Ah, cool. And why I don't see my observed values here as well, because it will be interesting to see them. Let's say that, let me see what I have here. I haven't applied anything to this. Observe flow is gauge 1. Okay, cool. Now I save it again and then I run it. And then I go here and then I run again, compute. Cool, and this is the observation, simulation, observe, calibrated for the, because actually what we are seeing here is the graph 1 at the station 1. Okay, so if you see here, there is a good fit here on the observe calculated, but here maybe we have to sort out what happened here. Maybe we can insert another sub-basin and so on. Okay, guys, this was the tutorial. Not so introductory, maybe it was a medium level tutorial. I hope that for you can find this tutorial helpful for your hydrological model with HEC HMS. My name is Saul Montoya. I am from Hatari Labs. We have a blog on knowledge sharing on open source software on water resources. Okay. Labs. This is our blog. Yeah. And we have a lot of tutorials, mostly tutorials on pumping test model, on solubility, on simulation, aqueous species, HEC, and so on. Okay, you can subscribe to a newsletter. Yep, and we have as well a Facebook page and a Twitter page and a LinkedIn profile. Okay, you can contact us. You can write your comments our website. We have some webinars. Those webinars are mostly on HEC HMS or Modflow. And soon, well, let's hope soon, we will have virtual courses for you. So you can pick a course on numerical modeling of water resources or groundwater resources or surface water. Okay, so my name is Saul Montoya. Please have a great day, and we hope to see you in another tutorial. See you. Bye bye. On the description of this video, you will have the model of this hydrological model. I save it. You will have, so let's say Tifton example. Let's say that this is V1 and let's make another compress because this will be V2 because actually you will have 2 steps of the same model. Okay, guys. See you guys, girls, and see you on the next tutorial. Bye bye. Have a great day.